Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, I solved question number 4 related with exercise number 4.2 relevant with the topic of speed, acceleration, velocity and direction of motion. We discussed these four physical quantities in the previous video for the following different type of vector functions. In today's video, I am going to solve the next question number 5 related with the same exercise number 4.2, chapter number 4, differentiation of vector function, FSC part 2 mathematics. So let's move toward question number 5. It tells that if v is equal to 2i minus j plus 5k and w is equal to I plus 2j minus 3k are the two vector functions, then evaluate the following derivative problems. So there are total 4 parts in this question number 5. Part number A tells that find the derivative of this function v plus tw with respect to t. So first we are going to putting the values over here and then we will differentiate the whole function with respect to t. So our v is 2i, so it become 2i minus j and plus pi k. Our v is 2i minus j plus pi k, and over here after this we have t, so t into w. W is I plus 2j and minus 3k. So after simplification it become 2i, it become minus j, it become plus pi k. Multiply t with each and every term, it become ti plus 2tj and after this minus 3tk. Now after this over here we have 2i, over here we have ti, so take out I common, so inside we left with 2 and over here we left with a t. After this from minus j and 2tj, take out j common, so inside we left with negative 1 and over here we left with a 2t. And after this in pi k and minus 3tk, we let's suppose take out k common, so we left with pi and over here we left with negative 3t. Now differentiating each and every term with respect to t, so derivative of a constant 2 is 0 and derivative of t with respect to t is 1, so it becomes just I. And after this plus j will come down as it is. Derivative of negative 1 is 0 because this is a constant. Derivative of 2t is just 2. And after this plus k into derivative of pi 0 because this is a constant and negative 3 derivative is just negative 3. So the result will be I, it become plus 2j and it become minus 3k. So this is actually the required and desired answer. Now move toward the second part, part number B. It tells that find the derivative of v dot t power 4 w second time with respect to t. So move to the solution of this part number B. First we simplify v dot t power 4 w and then we will differentiate the required and desired answer twice with respect to t. So our v is actually 2i, so it become 2i minus j and plus k. This is actually our v. Over here we have dot product. And after this over here we have t power 4 into w. Our w is I plus 2j and minus 3k. Now by simplification it become 2i minus j plus pi k and dot multiply t power 4 with each and every term. It become t power 4 into I plus 2t power 4j. Multiply the same t power 4 with it, it become minus 3t power 4 and k. Now after this in dot product we multiply the coefficient of the same component. The same over component is I and over here the component is I. So multiplying their coefficient, over here the coefficient is t power 4 and over here is 2. So it become 2t power 4. After this the coefficient of j over here and over here it become 2t power 4 and over here it is negative 1. So it become minus 2t power 4. After this the coefficient of k and over here the coefficient of k. So the coefficient of k over here is minus 3t power 4 and over here it is 5. So multiplying them with each other it become minus 15 and t power 4. Now by simplification they are cancelled with each other because these are the additive inverse of each other. We left with minus 15 t power 4. Now we are going to find the derivative with respect to t double time. So differentiating this with respect to t first time, it become minus 15 into the power will comes to the front and we will subtract 1 in the power. So 4 minus 1 will give us 3. So it become minus 60 into t power 3. Now again differentiate for the second time, so it become d square by dt square. So minus 60 multiply 3 and subtract 1 in the power, so it become t power 2. So minus 60 multiply 3 will give us minus 180 into t square. So this is actually the required second time derivative. Now move toward part number C, the third part of question number 5. It tells that find the second time derivative with respect to t of t into absolute of v plus t square into absolute of w. So first we are going to find the absolute of v and absolute of w. So our v is actually 2i minus j and plus pi k and our w is I plus 2j minus 3k. Now you know that absolute is actually the square of each and every term. So over here we will take 2 square, and after this the coefficient of j is minus 1. So it become minus 1 square, and the coefficient of k is 5, so it's square. 5 square. And we take whole under the root of. So absolute of p will be 2 square gives us 4, minus 1 square gives us 1, and 5 square, you know that it gives us 25. So 25 plus 1, 26, 26 plus 4, it will give us under root of 30. Now finding the absolute of w by using the same logic of coefficient of I is 1, so it become 1 square, and plus of coefficient of j is 2, so it become 2 square, and plus of coefficient of k is minus 3, so it become minus 3 square, and whole under the root of. So our w will be 1 square gives us 1, 2 square gives us 4, and minus 3 square will give us 9. So 9 plus 4, 13, 13 plus 1 gives us 14. And absolute of w is actually under root of 9 plus 1, 10, 10 plus 4 under root 14. Now putting the values over here, so our t is actually, we will write it same t into absolute of v. Absolute of v is 30, and over here we have t square into absolute of w, so w is under root of 14. Now that tells that find the derivative of this with respect to t double time. So first we differentiate for the first time solution. So for the first time derivative with respect to t, you know that it is 1, so it become under root 30, and plus derivative of t square, you know that it is 2t, and under root 14 will comes down as it is. Now for the second time it become d square by t square, so under root 30 is a constant, its derivative will be 0, and 2 under root 14 will comes down as it is, because derivative of t is 1, so 1 multiplied 2 under root 14 will give us 2 under root 14. So the required second time derivative for a part number C is 2 into under root of 14. Now move to the last part of today's lecture, and the last part of question number 5, part number D. Find the derivative of TV cross t square w with respect to t. So first we are going to simplify TV cross t square wv. So t will come down as it is, our v is 2i minus j plus 5k, put over here, so it become 2i minus j plus 5k. After this we have a cross product, and after this we have t square into w. W is I plus 2j minus 3k, put over here. Now multiply t with each and every term, it become 2ti minus tj and 5tk. After this multiply t square with each and every term, it become t square I. T square into 2j gives us 2t square j, and t square multiply minus 3k gives us minus 3t square k. Now remember, in the cross product we will multiply the same component directly their coefficient, but over here in the cross product we will use the determinant rule. In the first matrix we will, in the first row we will write ijk, and the second row we will write the first function, which is 2t, the coefficient of j is minus t, coefficient of k is 5t, and the third row we will write the second function. So coefficient of I is t square, coefficient of j is 2t square, coefficient of k is minus 3t square. Now expand with row 1. So for row 1, let's suppose I take I, so for I will cross this row and this column, I left with minus t, 5t, 2t square and minus 3t square, and the sign will be plus. After this our sign will be negative and j. So for j I will cross this column and this row, I left with 2t, 5t and t square into negative 3t square. After this we have plus sign, so plus k, and after this cross this column and this row, I left with 2t minus t and t square into t square into t square. Now using this formula of determinant, let's suppose a b c d, so the formula will be ad minus bc. So AD minus BC, AD minus BC, AD minus BC. By simplification, it will give us minus 7 t power 3i plus 11 t power 3j plus 5 t power 3k. Now over here we have d by dt. It means that we will differentiate this at last. So differentiation of minus 7 t power 3 will give us minus 21 t square I. Differentiation of 11 t power 3 gives us 33 t square j. And the differentiation of 5 t power 3k will give us 15 t square k. So this is actually the required and desired answer. So with this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about interesting problem related with calculus and mathematics. Thank you.